So density of aluminum is 2600 kilogram per meter cube. Okay, so we have to find out the net buoyant force. They are asking for the buoyant force. Okay, so the volume of the core is pi by 4 into d square into h. We know the equation for that. Then pi by 4 is there. D is given in question, that is 100 millimeter. 100 millimeter, that is the cylindrical hole having diameter of 100 millimeter, that is 0.1 square into h. H is the length, that is also 100 millimeter, so 0.1. Okay, so then we will get the volume. Okay, so the net buoyant force is rho L. We have already solved on problem by using this equation, rho L by rho core into V core into G. We have already solved this type of question. Okay, so rho Al, that is given in question, rho core into V core into G. Okay, so density of that core is, that casting is 1600 kilogram per meter cube. That is also given question. So we will get as 1000, then 9.81, then volume is this much, then we will get the answer. So this is the equation, net buoyant force. This is the equation for finding buoyant force in terms of density. That is, if one thing is going to going to float over another, then we can use this equation. We have to take the difference between that, then volume into G. That will give the net buoyant force. So we have to remember this equation. Okay. Next, a spherical balloon with a diameter of 10 meter shown in figure. Okay, then below is used for advertisements. Okay, this is used for advertisements. Because of that, they have given us GATE 2014 just for a representation. Okay, the balloon is filled with helium. Okay, about how much? 2.08 kilojoule per kilogram Kelvin at ambient conditions. That atmospheric condition is 15 degrees Celsius and the pressure is 100 kilopascal. Okay, assuming no disturbances due to wind, the maximum allowable weight of the balloon material and the rope required to avoid the fall of balloon. Okay, so how much will be the maximum weight of that balloon that should avoid the fall of balloon? Okay, so if the mass of the weight of the balloon is greater than the thing we are going to find out, then it is going to fall down. Okay, so at what rate we can increase that? Okay, so mass of the balloon, we have to find out the mass of the balloon and mass of the rope. Okay, this is the rope. So volume, that is 4 by 3 pi r cube. It's a sphere. Okay, 4 by 3 pi r cube. Then we will get the volume. Okay, then we will get the volume. Then density of helium, that is given in question. How much the balloons are filled with helium, that is H is equal to 2.08 kilojoule per kilogram. So gas constant is given, that is 2.08 kilojoule per kilogram, that is given. Then if we know that, we can find out the density using this equation, that is rho is equal to P by RT. Rho is equal to P by RT. Rho is equal to P by RT. P is, how much is P? That is 100 kilopascal divided by R. R is given. The gas constant is given. That is 2.08 kilojoule per kilogram Kelvin. We convert that into joule per kilogram Kelvin. Because of that, 2080 into temperature. What is temperature? 15 degrees Celsius. Convert that to Kelvin, because this is also in the form of Kelvin. Okay, so 288. Okay, then we will get the density like this. Okay, then what is the total mass of the balloon? The mass of the helium plus mass of the balloon material. Mass of the helium inside that plus mass of the balloon material. Okay, the total mass will be this plus this much. Okay, that is this into this, that is rho into what? Rho into V. That is the total mass. Rho into V is the total mass. Okay, then mass of the air. Next we have to find out the mass of the air. Okay, that is rho is equal to P by RT. Okay, P by RT, mass of the air, because here we have the air. Okay, so it is don't want to, if the mass of this material is greater than the mass of this air, okay, then it will going to fall down. So we have to find out the mass of the air here, okay. So mass of the air is this much, the same equation, P by rho T, okay, P by rho T. So this is the gas constant for atmospheric air, okay. So mass of displaced volume of air, that is this much, mass of displaced volume of air, okay. Then that is we have got the volume of balloon. The volume of balloon as 523.33. Okay, so that balloon is actually situating in the air. So that much air is displaced from the atmosphere. Okay, that much air is displaced from the atmosphere. Because of that, this 1.2 into that much volume. That will give the mass of the air displaced. That is rho into V. Rho into V. Okay, so that will give the mass of air displaced from that area. So the next buoyant force will be this thing minus this one. Okay, so this is the net buoyant mass. Okay, this is the net buoyant mass. So this m into g will give the maximum allowable weight. Okay, so next is for a floating body, the buoyant force acts at the centroid of the displaced fluid. Okay, this is already we have discussed in theory portions. For a floating body, the buoyant force acts at the centroid of the displaced fluid. Okay, so next is an inverted U2 manometer. It is about inverted U2 manometer. We have to divide it into left limb and right limb. We have to write the pressure equations at this is the lower level. We have to take the lower level of this and we have to find the pressure at this point and this point. We have to write the equations. We have to take the equilibrium condition. We have to equate that on the left limb and right limb. Then we can easily find out whatever maybe they are asking. They are asking this is PA, this is PB. They are asking PA minus PB. Okay, they are asking this. If you know the way to write that equation, we have already solved more than 4 or 5 questions regarding this. Okay. In previous in practice questions and this program. Okay, so just we have to write the equations on the left limb and the right limb. Okay, pressure at the section 1 in the left limb. Okay, that is PA. This is inverted. Because of that, we have to take the, normally if the U2 manometer is like this, we have to take all is PA plus like that. If it is inverted, we have to take this sign as negative. Okay, we have to take this as positive, PA and PB as positive, and all other pressure due to these columns, these liquid columns, all of the pressure due to these liquid columns, we have to take it as negative. That is the only one difference. Okay, because it is inverted U2 manometer. Okay, so PA minus this one rho GH2. Okay, rho GH2 plus what? This much air. Okay, rho GH1, this much air, rho GH1. Okay, then is equal to this PB minus this much rho GH3. This much. Okay, this much. Sorry, H1 plus H2 plus H3. That is rho into G into H1 plus H2 plus H3. Okay, so because up to here it is same liquid, but here what is that? Here it is 2 types of liquids are there. Okay, so up to here we have to find out, we have to write the equations. Then what we will get? Then by solving that, we can easily get PA minus PB is equal to this much. So the only thing is we have to know about how to write the left limb. Left limb and right limb equations. Because of inverted, we have to give the negative signs. Okay, we have to give the negative signs. Okay, just work out this problem. Okay. Next is a large vessel shown in figure contains an oil and water. Here this oil and water is there, and a body is submerged at the interface of the oil. Such that 45% of its volume is in the oil. 45% is in oil, and the rest is, that is 55% in water. Okay. The density of the body, we have to find out the density of the body. So specific gravity of the oil is 0.7 and density of water is 1000. That is given. Okay. So volume of oil is equal to 45% of total volume V. Volume at water is equal to 0.55% of V. because this is about 45, this is about 55. Okay, so for equilibrium, net buoyant force is equal to FB water plus FB oil. Okay, that is the buoyant force acting due to the oil plus buoyant force acting due to the water. Okay, so that will be the net buoyant force, that is MB into G is equal to rho W V into G plus rho oil into V into G, that is force. Okay, so MB, we have cleared that all G, this G, this G and this G. These are the very basic equations. Okay, so go through that theory portions, then we will know about these equations. Then rho B into V, that is mass. Mass is equal to density into volume. Mass is equal to density into volume. So we have write that. Then we can easily solve. We will get the density of that body as this much. Only we have to use this equation. That is, the net buoyant force is equal to the sum of the buoyant force created due to the water and the oil. Okay, so by solving that we will get. So M is equal to rho in V and the buoyant force is equal to rho into V into G. Okay, these are the equations we have to note. Okay, so go through the theory sections also. Next is consider a frictionless, massless and leak-proof plug blocking a rectangular hole of dimensions 2r into L at the bottom of an open tank as shown in figure. Okay, the head of the plug has a shape of semi-cylinder of radius r. The tank is filled with a liquid of density rho up to the tip of the plug. Okay, then the gravitational action is G. Neglect the effect of atmospheric pressure. So what we have to find out is the force required. We have to find out the force required to hold the plug in position. That is, we have a cylinder like that. Inside that we have inserted a plug. Okay, this is the front view and this is the side view. This is the front view and this is the side view. Okay, so we have to find out this force to hold that plug like that. Okay, that is the thing we have to find out. Okay, so volume, total volume is equal to 2r into L into R, 2r into L into R. Okay, then 2r square into L, 2r, that is R plus R, 2r into L. L is the length that we can see here. Okay, L into R, that R is the radius. Okay, that is 2r into L into R, that is 2r square into L, that is the total volume. Okay, so V1 is equal to half into pi r square into L. Then F is the weight of the fluid. What is weight of the fluid? Weight of the fluid is equal to rho Vg, rho Vg. Weight of the fluid is equal to rho Vg, that is total volume minus this much volume, this much volume, this much volume. V1 means the volume of the plug, volume of the plug. Okay, so we have to minus that, then rho G is there. Then after finding that, we will get the answer is like this. This much force we have to exert to hold that plug in position. So what is the concept behind that? So this is a plug. This is a plug having volume V1. This is a plug having volume V1. And this volume total means this much. The volume total means this much. That is 2r into L into R. This height into width into thickness. Okay, height into width into this thickness that we have taken, that is 2r square into L. Okay, then V1 is the volume of this thing only. The V1 is the volume of this thing only, that is pi r square into L divided by 2. So like a semicircular one. Okay, so semi-cylindrical one. Okay, so pi r square into L divided by 2. Okay, then from the total volume we have to subtract that for the weight of the fluid, for finding this weight of the fluid, because of that V total minus V plug, that will give the volume of this water, that into rho G will give the weight of this fluid. Okay, so we have to exert a force which is equal to the weight of the fluid from the upward direction, because this weight of the fluid here is going to push the plug downwards. Okay, then that will displace that plug. We don't want to allow that. For that we have to exert an equal pressure upward. Okay, so that pressure must be equal to the weight of the fluid here. Because of that we have done like this. Okay, so because of that we have find the total volume, the volume of the plug, then subtracted that, then we will get this much of volume, then into rho g, that is give the force, okay. Then that will be equal to the upward force. That is the concept, okay. So these are the previous year questions regarding the chapter fluid statics. So go through the theory classes and solve these problems on your notebooks, and we can surely crack the questions from this chapter, okay. Thank you.